So how do you correct errors? Well, what we're going to do is we're going to define H is equal to, well, what we're going to do is we're going to take this parity check piece of the matrix and stick it up here. And now we have that GH equals 0. Why? Well, in general, let's say G equals IS, H equals minus SI. So S equals minus S if they're binary. GH is equal to, well, just multiply I minus S plus S times I. Minus S plus S equals 0. So GH equals 0. And in fact, so G is a 4-dimensional subspace of a 7-dimensional thing. H is a 3-dimensional subspace, or the column space of H is a 3-dimensional subspace of a 7-dimensional space. And H is actually the perpendicular subspace to G. And you will notice that H and G have a lot of the same vectors in them. Or maybe you won't notice that because it's not completely clear given this, but every vector in H, every row here, is also a vector in G. And that's because, well, if you take 1, 1, 1, 0, 1, 0, 0, and take the inner product of itself, you get 4, which is 0. So even weight vectors are perpendicular to themselves, so a vector can be perpendicular to itself. And that's going to be very important later when we get to the quantum Hamming code. But right now, it's less important.